Hey guys, welcome back. We are going to actually skip section 2.11 for now. I want to have enough time to finish something up on Friday. So we're going to skip over to 2.12, which is logarithm function manipulation, which just is a fancy word for changing. So let's look at some of these properties. You've probably seen these properties before, but this is properties of logarithmic functions. We've started to talk about this. I started understanding how to cancel logarithms, but today we're going to talk about expanding and condensing. So we can use the product property in this way, where I see a product of two numbers or two variables, and I can split them up and expand them. Expanding meaning it's getting larger, getting bigger, so that we have two separate log b's, where we now add them up. So log base b of x times y is the same as log base b of x plus the separate log base b of y. And this is because addition and multiplication have a relationship where multiplication is just simply repeated addition. So that's if we want to expand, but also we can work this backwards to condense. Okay, so let's say, for example, you had log base e, which is the ln, or natural log. So let's say you had ln of 6 plus the ln of y. Again, ln is just log base e. And I wanted to condense this down so it's not two natural logs, but one. So we can use the product property in reverse, knowing that adding two separate logs is the same as multiplying the same log with the same base. So let's look here. Because these are both natural logs, we know they both have a log of the same base of e. Because they're adding, we know that we can change this down and condense it to one natural log of 6 times y. Let's look at the next one. So here we've got the quotient property. And the quotient property says I can take two terms, numbers, or variables being divided to a log and split them up into two separate logs by subtracting. And that's because repeated subtraction is division. So we know log base b of x minus log base b of y. We can also use this in the reverse if we want to condense it instead of expanding. Again, we can see here we had one log and now we have two, so that was expanding it. Now let's condense it. So with the same idea, using the same property but backwards, what if I had log base 4 of 3y and subtracted log base 4 of z? I could condense this down from two logs to one because they have the same base. This is really important. If they don't have the same base, this isn't going to work. So they do have to have the same base. So here's log base 4. But when we subtract logs, we're actually dividing. It's a quotient. So we're going to put 3y in the numerator and z on the denominator. Get in the habit of putting your parentheses around anything when you're dealing with logs as well. And then the last one here, our power property, we started to talk about this today, is when we have a log of a value with an exponent, that can be equivalent to the exponent turning into a coefficient in front. So here's our coefficient k times log base b of x. So that would be expanding and making it larger. But if I wanted to use that in the reverse to condense it, I could use the same idea where I have the natural log of x times z. And if, let's say, I had a 10 in front here, that would be the same as the natural log of x z with a 10 in its exponent. So slightly smaller. All right, so let's do some examples of expanding and condensing. Expanding means we're going to take something that's smaller and make it larger with as many logs as possible. So we're going to expand here and here. This should be part B, by the way. So let's expand what looks here like a product. So we're going to use our product property. Okay, so here's our product property, where we're going to separate every product that we see. We're going to separate it and make it its own log. So I see 1, 2, 3 pieces of the product. So I can say log of 4 plus log of x squared plus log of y. We can see one more thing here. Besides the product property, I can also see the power property that we can apply here because we have a power of 2. And any power of 2 can be brought down in front as a coefficient to expand it. So we would have this right here would become 2 times the log of x. Bring down the rest. And this is as expanded out as we can go. Let's look at the next one. Here for part B, if I wanted to expand this out, I see a couple of things going on here. The most pronounced is I definitely see we have a quotient of a numerator and a denominator. So let's split that up using the quotient rule, or the quotient property. So 2 separate logs for the numerator and the denominator. So we're going to say log of the numerator, which is 3rd root x plus 5, minus, as a separator, log of y squared. So now that we've applied the quotient property, we can also, so this is our quotient property, now we can see that we also have some powers here. So I know that power rule means I can pull it down in front as a coefficient to make it larger or expanded. So this would be a minus 2 log y. And then we can also recognize, remember, anytime you have a root, this is actually considered a power. So I'm going to rewrite this as a power. So log of the x plus 5. And the 3rd root is equivalent to a power of 1/3. So again, we can take that power and move it out in front as a coefficient. So this would be 1/3 log of x plus 5. Bring down this part, minus 2 log y. And that's as expanded as we can go. All right, so this was our expanding where we're making as many logs as possible with no powers. Now let's talk about condensing. So condensing means we want to take multiple logs or expressions down to 1 and have no coefficients if possible. So I see here that we have 2 log bases of 2. So because these have the same base, we can condense them down. So before we do that though, just like we did powers last when we were expanding, we're going to do powers first when we're condensing. So we're going to bring those powers from coefficients up to those powers. So we've got log base 2 of x squared plus log base 2 of y plus 1 to the 1/2 power. So all I did there is this stayed the same, but this 2 becomes a power. Okay, so now that I've dealt with the power rule, now let's use, okay, so I know addition is basically the product property backwards. So here's my addition property going backwards using the product. So I know that because these are the same base, I can turn them into a product. So the base log 2, and then we take x squared times this. So we're going to say x squared times y plus 1 to the 1/2 power. And that's as condensed down as we can do. Let's look at this one. So again, whenever we're condensing, we're always going to deal with the powers first. So take those coefficients and turn them into powers. I see these. So we've got a log base 3 of ab squared to the 2 minus log base 3 c to the 3rd plus log base 3 of d now to the 1/3 power. So we also see that we have all the same logs. So because we have all the same logs, now we can condense them down to 1 log. Remember, this is subtraction. That lends itself to the quotient rule. This is addition, which tells me it's going to be product rule. So knowing that we have all base 3 logs, we're going to use this one first. So we go ab squared. Now remember, minus is division. So we're going to divide by that c to the 3rd. And then this addition means to multiply. So we're going to multiply that again to the numerator, where this is d to the 1/3. And this is as condensed down as we can go. Okay, so let's kind of go back and look at something we've talked about a little bit, our change of base formula. There's two different ways to apply this. Remember that on your calculator, the log key is log base 10, and that in your calculator, the ln key or natural log key is log base e. Okay, so once you understand that, we can change the base of any log to really anything. It doesn't have to be just 10 and e, it can be anything, but it's especially helpful if these are the types of logs that your calculator can do easily. So let's change log base 4 of 12 as a common log. So that means I'm going to take the common log of 12 and put it the common log over 4. Okay, again, you could use any other base here, but we're going to use common log because that's what's in our calculator. Let's put this as a natural log. So if I want to change the base to base e, I'm simply going to take log base e, or the natural log of 12, and put it over the natural log of 4. If I take both of these values and put them into my calculator, they're going to both give me the same value. Remember that this little shortcut, I don't like the way he said that, but this is a shortcut. If you have a TI-84 plus or higher, if you go to your math key and you hit the up button, you can search through and find option A, which is the log base option, and it will give you that set up so that you can change the base directly. All right, let's, and actually we're not going to do the graphical application this time, so that